Hello everyone, my name is Soham Deshpande and today we are going to learn about circular queue and implementation of circular queue using array. First of all, what is circular queue? Circular queue is a linear data structure in which the operations are performed based on FIFO, that is first in, first out principle, and the last position is connected back to the first position to make a circle. It is also called as a ring buffer. In a normal queue, we can insert elements until queue becomes full. But once queue becomes full, we cannot insert the next element even if there is a space in front of queue. So here circular queue is used. The operations on circular queue. Front, get the front item from queue. Rear, get the last item from queue. Enqueue, this function is used to insert an element into the circular queue. In a circular queue, the new element is always inserted at rear position. There are following steps for enqueue. First, check whether queue is full. To check, we have to see the following condition: rear is equal to size minus 1 and front is equal to 0, or rear is equal to front minus 1. Second step, if it is full, then display queue is full. If queue is not full, then check if rear is equal to size minus 1 and front is not equal to 0. If it is true, then set rear is equal to 0 and insert element. Dequeue. This function is used to delete an element from a circular queue. In a circular queue, the element is always deleted from front position. Steps. First, check whether queue is empty, means check front is equal to minus 1. If it is empty, then display queue is empty. If queue is not empty, then step 3. Step 3 is check if front is equal to rear. If it is true, then set front is equal to rear is equal to minus 7. Else check if front is equal to size minus 1. If it is true, then set front is equal to 0 and return the element. This is the algorithm for circular queue. Here we are going to use structure. So the keyword struct queue. We will declare rear and front as integers, size as integer, and an integer pointer array. Constructor queue which has parameter as s, which is size. Front is equal to rear is equal to minus 1, that is we initialize front and rear. Size equal to s, and we will assign array a space by array is equal to new int s. Following are the functions: void enqueue with the parameters value, int dequeue, and void display queue. Function to create circular queue. We have to check the condition, and if it is true, then printf queue is full, return. And if the condition is false, then we have to check again one more condition, that is front is equal to minus 1. If it is true, then front is equal to rear is equal to 0, that is we have to initialize front and rear to 0, and array rear is equal to value. Else if rear is equal to size minus 1 and front is not equal to 0, rear is equal to 0, array rear is equal to value. Else we have to increment rear, array rear is equal to value. The next function is dequeue, which is used to delete element from circular queue. We have to check for the first condition, if front is equal to minus 1. If it is true, then printf queue is empty and return int min. Integer data is equal to array front is equal to minus 1. If front is equal to rear, then the following will be executed, that is front is equal to minus 1 and rear is equal to minus 1. Else if front is equal to size minus 1, front is equal to 0, else front is incremented and return data. The next function is to display the queue. We have to check if front is equal to minus 1, and if it is true, then we have to print queue is empty and return. Else we have to print elements in circular queue, and for that we have to first check the condition rear. If rear is greater than equal to front, then for int I is equal to front, I is less than equal to rear, and I plus plus printf %d array I. So this is a for loop, and all the elements in the circular list, circular queue will be printed. Else, for int I is equal to front, I is less than size, I plus plus, printf %d array I. For int I is equal to 0, I is less than equal to rare, I plus plus, printf %d array I. The time complexity of NQ and DQ operation is big O of 1, as there is no loop in any of the operation. The application of circular queue are as follows. First, memory management, second, traffic system, and third, CPU scheduling. Memory management. The unused memory locations in the case of ordinary queues can be utilized in circular queues. Traffic system. In computer controlled traffic systems, circular queues are used to switch on the traffic lights one by one repeatedly as per the time set. CPU scheduling. Operating systems often maintain a queue of processes that are ready to execute or that are waiting for a particular event to occur. Thank you.